Yeah, welcome back all of you to these sessions on engineering mathematics. So let's continue this today's lecture. Basically today is lecture number 5 of multivariable calculus, and in today's class the main prime focus could be on the solving multiple integrals actually. Okay, so but before solving directly the multiple integrals, I've given you some homework in the last lecture, so let us have a look at that particular lecture. Okay, and before we straight away go into the content, so this is the Telegram channel for the updates on Wallah English YouTube channel actually. So any content that rollouts on this channel will be first displayed here. So if you I advise you to follow this because you won't miss the sessions which are going live on this channel actually. Okay, also this is our personal channel basically managed by me and my students at PW. So if you feel that you need some advice or at any point, if you feel that I can help you out, you can just join this by just scanning this code, of course. Okay, I also strongly advise you to install Unity app so that you have a single location tracking of all your content, like the polls, important points, okay, doubts, all these points you have at a particular location, of course. So you can install this, and you can just, before asking doubt, you can type exclamation doubt, and similarly before writing any note point, if you exclamation note, and if you make these points, then they get stored at this particular location actually. Yeah, good evening all of you. So let's discuss in the last lecture. So in the last lecture we have seen the concepts of maxima and minima in multivariables, right? So maxima and minima in multivariables, and of course we have seen if you have any function, so z is equal to f of x comma y, the first step we calculate is p, which is fx is equal to 0 and q is equal to fy is also equal to 0. Then by solving techniques, yeah, good evening all of you. So by solving techniques we solve these things and we get a stationary point. Okay, so we get this stationary point x0 y0. So once we get this stationary point, we calculate r value, which is fxx at this stationary point x0 y0. Similarly s, which is fxy or fyx again at x0 y0, and t, which is fyy at x0 y0, of course. Okay, then we have given certain conditions, of course, based on the gradient and the okay, in two variables. Normally if you calculate based on the rt minus s square value, so if r greater than 0 and rt minus s square is actually greater than 0, so this implies a minimum, of course. Okay, so we have seen that. And 2, if r greater than 0, and rt minus s square is okay, see, if r is less than 0 and r is less than 0 and rt minus s square is positive, then in such case we have a maximum, of course. Okay, so we have a maximum. Then if rt minus s square is equal to 0, then we got a saddle point here, so this is saddle. And 4, if rt minus s square is negative, then the matrix, okay, basically here this rt minus s square value is negative, so in such case we have this we can't identify the nature of the function. Okay, so we can't identify nature of the function actually here. Okay, so we can't identify nature of this singular point x0 y0 actually here. Okay, so these are the points which I have given you in order to calculate the maxima and minima concept. So I want to calculate DA, and DA maths weightage is used, so I just want to focus on your lectures and practice thoroughly. Yeah, definitely. Okay, so that will help you. And so let's see. Yeah, basically whatever the single variable calculus we have till now, I have taught only linear algebra. Okay, so in that we have covered, and also in single variable calculus only we have one variable optimization. Single variable optimization is what we have, and single variable optimization is something like the maxima minima concept. And of course there is slight thing which is called the convex sets normally, so we'll discuss again about the convex set hopefully at the end of this course. Okay, so no issue. And also when examination comes very close, we'll try to take a one-shot sessions based on the complete topics, so don't worry, everything gets covered. Okay, then we have also seen the constraint maxima or minima, constraint maxima minima concept, so which is of course again called as Lagrangian multipliers, method of Lagrangian multiplier actually. So we have seen the working procedure to this, and we have solved an example as well. Okay, so we first form this function capital F of x y z, so which is the function that is to be optimized either maximum or minimum plus lambda times the constraint function, which is phi of x y z minus c whatever. So this is the function, and we work out with this particular function, of course. Okay, yeah, I gave homework in the last lecture, correct? We'll see now. Okay, So these are the things which I have covered till the last lecture. Okay, so in today's class, basically we have given some homework on this constraint maxima and minima and one question from this maxima and minima. So we will actually continue this and then we'll move to multiple integrals. Okay, so let's have a quick idea. And also in today's class, I'm going to teach you transformations. Like let's say if there is a certain integral in Cartesian coordinates. Okay, but sometimes what happens, rather than solving that integral in Cartesian, it's very much advantageous to solve it in polar coordinates or as other coordinate systems basically. So we will see how we can actually convert one any function or any integral from one Cartesian to another from one system to another coordinate system actually. Okay, so these are the things. But before we straight away go for today's topics like multiple integrals, I'll also teach some applications and coordinate transformations. So before I straight away start these topics, let's discuss the homework first. So this question, the distance between the origin and the point nearest to it on the surface z square is equal to 1 plus xy is dash, of course. Okay, so solve this question. What is the minimum distance between the origin and the point nearest to it on the surface? Z square is equal to 1 plus xy. So this is a homework question, and if you have already solved, then enter the answer in 30 seconds. Come on, enter the answer if you have already solved this question. When we will teach transformation in today's class itself. Yeah, just a minute, I'll have a bit of water. So meanwhile, just enter this answer. 3 is the answer. So the minimum distance is 3. Let's check it up. Okay, so first of all, you have this surface solution. So let's say you have this surface. So this is some surface, z square is equal to 1 plus xy. So this is some surface actually. Now let's see, you have a point here, say xyz, and let's say the coordinate system is such that the origin is somewhere here maybe. Okay, so this is the origin. So obviously different points have different distance from this origin, but there is one point which is actually near to this. Okay, 2, 3, let's check it up. What's the answer? So let's say this distance is actually the minimum distance. Okay, so let's say this is the minimum optimal distance, or basically the minimum distance actually. Okay, so let's see, if you try to understand something, the distance between the origin and the point nearest to it. Okay, so this is the origin and the point nearest to it on this surface, P, of course. So if this distance has to be minimum, can I say the square of the distance from this point to any point on this curve is also minimum? Correct, because if this is the minimum distance, then ultimately square of this value is also the minimum value for these possible combinations, right? Because I just want to avoid the calculation 1 by 2 root of all these things. So to eliminate that, what we are doing, if this distance is minimum, then the square of that distance is also minimum for all these points. Correct? Yes or no? Please type it in the chat box. Can you all get this? What I'm telling you here is the distance between this point A and this point P is minimum, implies AP square is also minimum only in this case, right? Because if you take any other point and if you calculate the square of the distance, it is definitely larger as compared to AP square. Yes? Yes or no? Can I say this? Because I just want to eliminate the square root in the calculation, that's all. Okay, nothing big deal about it. So let's see, consider AP square is equal to f of x comma y. So what is the distance between point A and point B? Root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, but it's a whole square. So x square plus y square plus z square. Now you want the minimum value of this, but one condition is this point P is on this particular curve, z square is equal to 1 plus xy, which means since this point should satisfy the equation, since P lies on z square is equal to 1 plus xy, can I say my function f of x comma y, I can replace it as x square plus y square plus 1 plus xy actually here. Okay, so can I do this? Yes or no? Now this is a function of two variables, and obviously I can use my standard procedure of maxima and minima. Okay, so let's see what I can do is, so let's follow the classical procedure. First step, P is equal to fx, which is 2x plus y is equal to 0, and Q is equal to fy, which is 2y plus x is also 0. And obviously these are two lines passing through origin, they have only one intersection, which is origin. Okay, so solving 2x plus y is equal to 0 and x or 2y plus x is equal to 0 actually. If you remember, I have taught you something called homogeneous equations, system of homogeneous equations in linear algebra. Okay, I can write this system as 2 1 1 2 x y is equal to 0 0. I have taught you this. Okay, and normally if this is a homogeneous system, then this system has only trivial solution if this determinant is non-zero. Okay, and for the system to have non-trivial solution, this determinant should be equal to 0. I have taught you these points. If you have remembered in 1.0 lectures when I'm teaching linear algebra, I have taught in case of homogeneous systems, if this has unique solution, which is nothing but the trivial solution, this determinant is non-zero, and clearly here this det is not equal to 0. So which implies 0 comma 0 is the only solution, So this homogeneous system afterwards. Okay, so if 0 comma 0 is the only solution, so ultimately stationary point is origin. Stationary point is origin. Okay, so if stationary point is origin, so let's calculate the second derivatives. So r is equal to, which is fxx, which is 2, then s is equal to fxy, so which is 1. Of course, if you differentiate this with respect to y, then ultimately you'll get 1, or if you differentiate this with respect to x, then also you'll get 1. Okay, then t, what about t? Fyy is equal to 2, and clearly this rt minus s square is rt minus s square is 4 minus 1, which is positive, and r is also positive here. Okay, so r is always positive. So this clearly implies the stationary point has a minimum. So this implies 0 comma 0 is a point of minimum distance. Minimum distance actually. So is this clear to all of you till this point? Can you all get this? Like, we have calculated the stationary point, then we have also calculated this rt minus s square value, which generally we have, and we figured out rt minus s square is positive, so there is no issue with location of minima and maxima, and r is also positive here, so definitely r is positive, rt minus s square is also positive, so we have a minima of course here. Okay, so that's why whenever there is a stationary point, at that stationary point we basically have a minimum value. So what is the minimum value? So therefore minimum value is equal to, so minimum value is equal to, so the is equal to f of x comma y at 0 comma 0. So if you replace 0 comma 0 in this function, so x equal to 0 and y equal to 0, so 1 is what you left, so this is 1. Therefore minimum distance is equal to square root of 1, which is 1, because this is the minimum value of AP square, okay, not AP. So that's why the minimum distance is square root of this value, which is of course less 1 in this case, because distance is always positive. So the minimum distance from origin to the point on this curve is 1 actually. Clear to all of you? Yes or no? Please type it in the chat box. Okay, so can you all get this? Basically the answer here is 1 in this case, because of this understanding the concept of maxima and minima in two variables. Every doubt got cleared? You would have solved this question using Lagrange's multipliers as well. Okay, no issue. See how you would have solved using Lagrange's multipliers. Look, I'll tell you. So clearly you can understand, if 0 comma 0 is the point, then z square is equal to 1, which means this point is either 0 0 1, or it can be 0 0 minus 1. One of these things would have happened, and the distance of both these points is actually 1. You could have solved this question using Lagrange's multipliers as well, using this technique. Let's see. Or this is one solution, or let me tell you, the function you want to minimize is using Lagrange's multipliers. So let's do this. So if you use Lagrange's multipliers, then what you have? Okay, so let's see. F of xyz is equal to the function which you have to modify, which you have to optimize, is basically this function x square plus y square plus z square, but these three variables are connected by this function. So maybe z square is equal to 1 plus xy. So if you pull it to the other side, z square minus xy minus 1. Okay, so this is the function actually. Using this technique as well, you can solve. Let us do a bit of calculation to understand. So this implies dou f by dou x is equal to 2x plus lambda into, and if you differentiate this with respect to x partially, you would get minus y is equal to 0. Okay, then dou f by dou y is equal to 2y minus or plus lambda into minus x is equal to 0, and dou f by dou z, let's write it here, dou f by dou z is equal to 2z plus lambda times of differentiation of this is again 2z is equal to 0, of course. Okay, so these are the three equations which you get from the function capital F of x, y, z. Now if you simplify this, this implies, so 2x or lambda is equal to 2x by y, and this is equal to lambda is equal to 2y by x, of course, 2y by x, and here lambda is equal to, so ultimately this 2z and 2z gets cancelled, of course. So if 2z and 2z gets cancelled, then lambda is equal to minus 1. So lambda is equal to minus 1 is what you get. So if you write minus 1 here, then if you write minus 1 here, minus 1 is equal to 2x by y, so which tells you 2x plus y is equal to 0. Okay, and this tells you 2y plus x is equal to 0 and lambda equal to minus 1, okay, which we got from this equation. So basically the connection between x, y and z is given by these variables, and clearly whatever you got here, 2y plus x equal to 0 and 2x plus y equal to 0 are the same values which are here. Okay, so that's how both are connected. So if you again solve this from here, the solution is obvious. So 0 comma 0 is the point, or values of x comma y. So if x equal to 0 and y equal to 0 for optimal condition, comma y is equal to 0 for optimal condition, and if you put x equal to 0, so once you get the relations, of course in this particular example you got the values as well. So if you substitute these values in this function, basically you know phi of x y z equal to constant, you have to substitute this relation in this function. So if you substitute, if you put x equal to 0 and y equal to 0, z always turns out to be plus or minus 1 again, so the answer would remain 1 actually. Is this clear to all of you? Did you understand in both the methods? One is solving the classical way and one is using Lagrange's multipliers. You can use any of the techniques. If you have used any of these techniques correctly, you would have got 1 as the answer. Okay, yeah, fine. So the correct answer is actually 1, which is here. So let's look at the poll. 1. Some of you have answered. Ashwini Kumar Biswal, good, fine. Okay, so let's see. I think I have given you one more question, basically this question. The minimum value of x, y, z if x plus y plus z equal to 3 is dash. So if some of you have solved, enter the answer. 30 seconds again. One. Let's see the minimum value of x, y, z if x plus y plus z is equal to 3 is. Let's solve this. So again we have the function to optimize and also this variable. So let's do that. Value of y, z if this f, then let's see, given f of x, y, z equal to x, y, z and phi the function x, y, z, x plus y plus z equal to or minus 3. So now if you form this function, plus lambda into equal to 0 actually. Okay, no sound is not coming properly. Any issue with the sound, guys? Any issue with the sound? Audio is fine, just confirm. So just confirm the audio once. It's fine, right? Because I think it's okay. Yeah, fine. Okay, good. So let's see. So if you then calculate dou f by dou x is equal to 0. So this tells you yz plus lambda is equal to 0. Okay, dou f by dou y is equal to 0 implies xz plus lambda is equal to 0. Dou f by dou z is equal to 0 implies xy plus lambda is equal to 0. So from the first equation you would get lambda is equal to minus yz, lambda is equal to minus xz, okay, and lambda is equal to minus xy. So this ultimately tells you that of course all three terms are cyclic. Like if you write minus yz is equal to minus xz minus xy, so ultimately this tells you x, y, z all are same, of course. Okay, so you got the relation for optimal condition up. So once you get the relation, then substitute x is equal to y is equal to z in x plus y plus z is equal to 3. That again implies you x plus y plus z is equal to 1 in this case. Okay, so if x plus y plus z equal to 1, so this implies x, y, z is equal to minimum optimal value of is 1. Okay, so that's what it is. Fine. So these are the homework questions which I have given you. So in today's class, let's start this with the concept of multiple integrals actually. Okay, so I hope these things are clear to all of you. So let's start this multiple integrals, which is one very easy topic actually if you know the geometry a bit well. But again, many people find it little difficult, but don't worry, we are going to start from scratch. Okay, so we had good enough experience in calculating single variable integrations. We have already completed that last week. So let's try to calculate this multiple integrals. So first of all, if you have a multiple integral, so type 1 constant limits. So you have constant limits, of course. Okay, so constant limits. So let's see how do you have this. So I is equal to, if f of x comma y is continuous and differentiable, is continuous and differentiable at each and every point, bounded by a region, or at every point in the region, at every point in the region bounded by x is equal to a, x is equal to b, y is equal to c, and y equal to d is d, then the integral of f of x comma y is evaluated as integral of f of x comma y is evaluated as, okay, so this is evaluated as, let's check this. So this is evaluated as I is equal to integral f of x comma y, let's say dy and dx. So then it tells you the first variable of integration is y, of course. So if the first variable of integration is y, ultimately the limits on this inner integral should be y limits. Okay, but since here it's constant, so y is equal to c to y is equal to d, because the limit, the region is bounded by the line y equal to, it's like a rectangle, right? X equal to constant, x equal to some other constant, x equal to a, x equal to b, y equal to c, and y equal to d. So it's bounded by 4 straight lines, which is actually some rectangle kind of thing. So let's see, y equal to c and y equal to d, and the second integrating variable is x. So the outer integral has the limits x equal to a to x is equal to b actually here. Okay, look, whatever m2 wherever. So let's see, if this is the y, or basically the element which is here is the immediately after function, that means that's the first variable of integration actually here. Okay, so if this is the first variable of integration, then ultimately this integral limits should be the limits of the same variable. And when you are doing this integration, first we'll try to evaluate this integral by treating x as constant. Okay, so we evaluate this treating x as constant, treating x as constant, actually treating x as constant. And this implies actually, so once you do this integral, then ultimately when you integrate this function with respect to y, treating x as constant, and if you substitute the constant limits in place of y, this complete function gets converted to some function of x. Yes or no? So this integral, when you calculate, gets converted to the form x is equal to a to x is equal to b, some function. Basically, after substituting the limits, integrating with respect to y partially, we have this single variable integration, which you are very familiar and expert by now to solve this integral. Okay, so this integral can be solved like this. And one more thing I'd like to say here, when this function is in variable separable form, means sometimes what happens, this function f of x comma y, we can actually split it into two functions such that one function is purely in terms of x and second function is purely in terms of y actually here. Okay, so in such cases we can directly calculate the integrals. So let's see, I would like to tell you in general. So if f of x comma y is variable separable function, then for constant limits on the integration, here you can add one more statement. Let f of x comma y is equal to g of x times h of y actually here. Okay, so let's say that you have, so f of x comma y is g of x into h of y. So you can split it into two functions, product of two functions, such that both are of two different variables actually. Okay, so for constant limits on the integration, then integral x is equal to a, x is equal to b, and please remember these should be constants. Okay, if they are variables you cannot split it, but if as long as they are constants you can do that. Y is equal to c, y is equal to d, f of x comma y dy dx. So now this can be written as integral x is equal to a, x is equal to b, y is equal to c, y is equal to d, and this function f of x comma y can be modeled as g of x times h of y dy dx. So this integration can be now written as, integral x is equal to a to x is equal to b, g of x dx multiplied with integral y is equal to c and y is equal to d, h of y dy. But please make sure this can be valid, or this can be written only if the variables can be split into, if only the integral limits are constants actually. Okay, if the integral limits are not constants, then you cannot do this actually. Okay, so is this clear to all of you? Let's work out an example to figure out whether this is valid or not. Okay, so I'll also show you how to evaluate in case of constant limits. Look, example, let I is equal to integral 0 to 3, integral 0 to 4, let's say maybe. So xy square plus 2xy dy dx. Let's say you take some function like this, okay, so that it's continuous everywhere with any region. So this is the integration that I ask you to do. Now if this is the integration that you have to do, so clearly this is y, so ultimately these are y limits, and it is x, so these are x limits. X is the outer variable of integration. Okay, so it's a constant. In case of constants, ultimately the inner integral is the inner integrating variable, and the inner differentiating variable, and the outer variable corresponds to the outer limits. Okay, so that's what you have. So let's see if I want to evaluate this. So first let us look at the procedure what I have given you. You should simplify this inner integral by treating x as constant, correct? So let's do that. So if you do this integration, this integral value is something like integral x is equal to 0 to x is equal to 3. Now when you integrate this part by treating x as constant, so let's integrate. First term, x is constant, integration of y square is y cube by 3. Okay, plus then again 2x is constant, integration of y with respect to y is y square by 2. Now this is within the values of y is equal to 0 to y is equal to 4. Okay, so this dx actually here. Now if you substitute the limits, let's see what you get. I is equal to x is equal to 0 to x is equal to 3, then if you replace these values, okay, so let's cancel this 2 and 2 maybe, quite simple. Then x by 3 into, now if you substitute limits, 4 cube minus 0 cube. So what is the value of 4 cube? 64, correct? So 64 minus 0 cube is 0 plus x into y square difference. So 16 minus 0 actually. So this whole function dx. So this tells you integral x is equal to 0 to x is equal to 3. And if you simplify this, 64x by 3 plus 16x. So 64x by 3 plus 16x dx. And if you take LCM, this is 48, 16 into 3, 48, 48 plus 64 gives you 112, correct? So integral x is equal to 0 to x equal to 3, 112x by 3 dx. So as I told you, upon simplification, this function is only now in terms of x. That's why I have mentioned here. Once you integrate this and substitute the limits, the function gets converted to a single variable integration with the integrand being only function of x. Is this clear to all of you now? When the limits are constants, how to convert this integral, or basically how to solve this integral? Is this clear to each and every one of you? Is this procedure in this particular question clear to each and everyone? Yeah. Just confirm. Yeah, all of you. Okay. Then let's see. Yes. Then let's do the integration. Then obviously, you know, this integral can be solved it by 112 by 3 is a constant. Then integration of x dx is x square by 2 within the limits 0 to 3, of course. Okay. So if you simplify, 2 cancel this 56 times, of course, and 56 by 3 times, if you put the limits, 9 minus 0. So again, this cancels 3 times. So 168 is the answer, correct? So yeah, 168. So this integral value is actually 168. Therefore, I is equal to integral x is equal to 0 to x is equal to 3, y is equal to 0 to y is equal to 4, x y square plus 2xy dx dy, or dy dx, sorry, dy dx is equal to 168. When these limits are constants, you should be a little careful, okay, in writing this order. So this is the value that I got actually here, okay. Then let's see, let us try to understand something. The technique what I have given you is xy square plus 2xy. This function as it is can be splitted as 2 parts actually, okay. So how we can do this? Let's see. Or since this limits is constants and the function can be separable, what I can do is, look, I is equal to integral x equal to 0 to x equal to 3, y equal to 0 to y equal to 4. The function which is here, if I take an x common, I would have got y square plus 2y dy dx, okay. Now since these limits are constants, constant values, and this function is splitted into 2 variables, into 2 functions, one containing only x and one containing only y, I can write this as, this is equal to integral x equal to 0 to x equal to 3, x dx, integral y equal to 0 to y equal to 4, okay. So y equal to 4, y square plus 2y dy, okay. So this is what you get. So what is the integration of this? X square by 3 within the limits 0 to 3 actually, sorry, x square by 2, okay. So x square by 2 within the limits 0 to 3 multiplied with integration of this guy is y cube by 3 plus integration of 2y is y square, that's it, okay. So within the limits 0 to 4. Let's substitute and let's calculate this value, how much it's going to be. When you put 3 here, it's 9 by 2 minus 0, so it is 9 by 2, that's it, okay. So it's directly 9 by 2 into minus 0, of course. Now coming here, 64 by 3 plus 16, 64 by 3 plus 16 actually here, okay. So 64 by 3 plus 16, and when you put 0, both are zeros. So if you simplify this, 9 by 2 into, and if you take LCM, 64 plus 48 is 112 by 3, which gives you, this is 56 and this is 3, so total 168 actually, okay. So it's also 168. So either this or this, you can adopt any technique to solve this integral. And please remember, you can do this splitting of integral only when the limits are constants, okay. Sometimes you'll see there are functions of x comma y in triple integrals and all, there you cannot do the splitting, okay. Please make a note, as I have told you, the splitting is done only if you have constant limits. Okay, that's important really. Otherwise, you'll end up with some wrong answers. Fine. So, is these two techniques clear to solve the integral? Yes or no? Please type it in the chat box. Okay. When they give you constant limits, you should be use little bit of text to solve that. So let's go for. Okay, so maybe let's. Okay, I have put an example here. Okay, fine, no issue. Let's go for another type. Okay, so type 2. Calculation of multiple integral in general domain. Multiple integral in general domain actually. Okay, so let's see. First method valid every equation. Yeah, first method is valid for every equation, but second the splitting has to be done only when limits are constant. Okay, so chalo, let's see calculation of multiple integrals in general domain. Okay, so let's see how do we calculate. So let's see, in general, if f of x comma y, if f of x comma y is continuous and differentiable, and differentiable in a domain D, then where the domain is bounded by the curves, y is equal to phi of x, y is equal to psi of x, some curves, and let's say x equal to a comma x equal to b. So this is some domain, let's say it is bounded. So when this domain is bounded, then we can get it as y equal to phi of x to y equal to psi of x, and x is equal to a comma x is equal to b, if and can write a condition phi of x less than psi of x. Okay, for all a less than or equal to x less than or equal to b, let's take this. Okay, this is just an assumption. So in such case, the value I is written as, then the integration of f of x comma y in the domain, f of x comma y in the domain is the integration of this is given as I is equal to integral f of x comma y. Now here you have option. Look, if this is the function, now you can choose your first integrating variable to be y or your first integrating variable to be x. Here doesn't matter, means you can write dy dx or dx dy depending upon the limits what you write. Again, in both the cases you have two different limits. Okay, we'll see one concept maybe some 20 minutes down the line, maybe something called change of order of integration. So we will see that, but right now what we are doing is we write it as y is equal to phi of x to y is equal to psi of x. Okay, and x is equal to a to x is equal to b. So in general, only the outermost limit or outermost integral has constant limits. Okay, every inner integral will have limits in terms of variables. So if you choose the first integrating variable y is the first integrating variable, y is the first integrating variable, so the limits on the inner integral should be y limits, but these y limits should be functions of x. Of course, if you are doing in 2D, okay, should be in functions or should be in terms of x actually here. So when you are writing y as the first variable of integration, you should definitely write the y limits on the inner integral as usual, but this y limits should be in terms of x. Okay, and the outermost integral should have constant limits like this, x is equal to a to x is equal to b, of course. Okay, so let's see. Or okay, we'll go for change of order of integration later. In general, it is defined as is I is equal to integral over the domain D f of x comma y d d. This dd in Cartesian is dx into dy, of course, because the function is in the form of x comma y. So the small elemental area. So let's say for example you have a domain D which is bounded by some curves. So this is domain D, okay, and let's say maybe your x comma y axis is somewhere here like this. So this is x axis and this is y axis. So in Cartesian coordinates, this small elemental area is chosen somewhere here in this element. So this length is dx and this length is dy. So the small elemental area of the domain is given by dx into dy or dy into dx, because area of the rectangle is dx into dy or dy into dx. So depending upon what we write here, what the first variable of integration we choose here, we write the limits accordingly. In case if you write x, if you choose x as the first variable of integration, then ultimately you should write x limits here, but these x limits should be in terms of y then in that case, okay. And the outer integral consists of y limits which are constants. Clear to all of you? We'll work out examples and we will calculate, okay. Is this clear to each and everyone? When you have integration with respect to two variables, then depending on what is the first variable of integration, you should write that particular limits, but that limit should be in terms of x. Of course, this is in again 2D integrals. When we go for volume integrals in tomorrow's class, I'll generalize this discussion for 3D integrals, okay, table integrals actually, okay. So let's solve this question. So first let us solve one question, okay. So the value of integral 0 to 3, 0 to x, 6 minus x minus y dx dy, okay. So clearly here it is like, sometimes they give you this to confuse you. Look, I is equal to integral 0 to 3, integral 0 to x, 6 minus x minus y dx dy. Look, try to understand one thing, dx into dy or dy into dx, it's same because it's just the elemental area. So when there is involvement of x here, okay, so observe carefully, there is involvement of x. So one of the limit of the integral is in functions of x, okay. So if this is function of x, then ultimately the integral is consisting limits of which variable? Can someone tell me? This integral 0 to x is there, so this is actually some function of x. If this is function of x, the integral is actually consisting limits of which variable? X or y? What variable limits does that integral contains? X limits or y limits? You can see there's a function of x as one of the limit. These are y limits then, correct? So these are y limits, x, good. So these are y limits. So y is equal to 0 to y is equal to x. So ultimately these are x limits then, in such case. X is equal to 0 and x is equal to 3 actually here. Yeah, good. So these are y limits, and ultimately then if these are y limits, the outer integral limits is x limits, okay. So let's calculate then. If this is y, the first variable of integration is y. As I told you, sometimes they change this to confuse you, okay, but you should apply it very thoroughly, okay. So when these limits are y limits, ultimately the first variable of integration should be y actually, okay. So let's see, if you integrate this, integral x is equal to 0 to x is equal to 3, integral y is equal to, or if you integrate this with respect to y directly, let's integrate. So 6 minus x is constant, so 6 minus x is constant, so constant integration is y minus integration of y is y square by 2 within the limits y is equal to 0 to y is equal to x. So this whole term multiplied with dx. So let's substitute the limits. I is equal to integral x is equal to 0, x is equal to 3, of course. Then if you replace y as x and 0, it is, the first term is 6 minus x into x, of course, 6 minus x into x, minus, when you replace x here, it is x square by 2, and when you put y equal to 0, both the terms are zeros, so this is the only function. So ultimately then this dx, it gives you integral x is equal to 0, x is equal to 3, 6 into x gives you 6x, minus x square by 2 minus 3x square by 2 dx actually here, okay. So then this tells you I is equal to, it's a single variable integration, so 3x square minus x cube by 2 within the limits 0 to 3. So if you put 27 minus 27 by 2, so 13.5 is the answer, okay. So therefore this integral value is 13.5. So therefore I is equal to 13.5 in this case, okay, because 27 minus 27 by 2 is 13.5 clearly, okay. So single variable integrations you are very familiar now, okay, so you can do it. Now let's see, one situation is I've given you these limits, so it's easy to calculate this integral slightly. Okay, so let's say instead of this question, if I did not mention the limits, but I have given you just a integral. Okay, so let's see, I is equal to, so fine. Okay, so let's see, writing the limits of integration. Okay, so writing the limits of integration, this is the main crux problem, writing the limits of integration. Okay, so let's see how do we write. I'll work out with the help of an example. So see here carefully. Let I is equal to double integral over the region R, let's say some function which is something like x square plus, or let's first take one simple function x dr or x dA you can take. Okay, so integral over the region A, x times dA. Let's say if I give you this region where A is, so after 6 minus x constant we write minus of y square. Is it? Let's check it. We have done some mistake. So let's, where 6 minus x minus only, no? Minus, because you have a minus sign here. Okay, after 6 minus x constant why we write minus of y square, because if you are integrating this integral 6 minus x minus y dy, okay, and you want to treat x as constant, so this 6 minus x is a constant, so this integral can be written as 6 minus y minus y, 6 minus x actually here, 6 minus x minus y dy. Now when you are integrating this, if this is constant, the integration value is 6 minus x into y, then after this minus sign is there, so minus y square by 2 actually here, that's why there is a minus sign. Okay, Ajit? Yeah, is this fine then? Hello, let's see the question what we are solving actually. So where A is the region bounded by the curves, A is the region bounded by the curves, let's say maybe x axis, y axis, the line y equal to say maybe some, or the line x is equal to, first let's say y is equal to 3x some variable, okay, and x is equal to 9, let's say. Okay, so x is equal to 9. So let's say this is the region. If I have given limits on this integration, now you know how to calculate this. Okay, in first step, clear? So thank you. Okay, fine. So let's see here, instead of writing this integration, if I have given you an integral like this by giving the limits, you all know how to integrate now. Okay, you have seen the procedure. But let's see, when you get an integral like this, then how to write the limits. Okay, so point number 1, first point you should draw is look at all these curves and plot all these functions. Okay, so let's see. First, identify the curves. Given curves are x axis, so y equal to 0, y axis x is equal to 0, y is equal to 3x, x is equal to 9, of course. Okay, so x is equal to 9. So let's plot these curves. So if you plot, let's identify. I have taken a simple example, eventually we'll complicate the examples. So let's see, this is x, of course, this is y axis, horizon, x, y, then y equal to 3x, obviously it's a straight line passing through horizon, so y equal to 3x, maybe something like this, more steep. This line would be more steeper actually. So y is equal to 3x, then x equal to 9, let's say. So x equal to 9, so maybe x equal to 9 is somewhere here. This is x is equal to 9 actually here. Okay, so x is equal to 9, and this is x axis, which is y is equal to 0, and this is x is equal to 0 actually. Now clearly this is the region which is bounded. Okay, so this is the region which is bounded, means basically this region which is inside is region A. Now we have to evaluate this function x in this complete area. Okay, so how do we evaluate? Look, let's see, I is equal to integral over the region A, x times dA. So let me tell you how to write these limits. This part is very crucial, so please listen very carefully. Okay, so integral x, so let's maybe choose the first variable of integration as y, no issue. So dy and dx I'm writing. So I have decided to choose my first variable of integration as y. When you choose first variable of integration as y, what we do is, let us consider a vertical strip in this region. Okay, so you consider some vertical strip in this region. So you consider this vertical strip in this region. So this is vertical strip. Now, if you move this strip anywhere inside this region, okay, so try to understand, since you decided to make y as your first variable of integration, you consider a vertical strip, and if you move this strip anywhere in this region from x equal to 0 to x is equal to 9, anywhere, always the lower boundary of the strip is provided by the x-axis. Yes or no? Correct? And upper boundary of the strip is always provided by this equation y equal to 3x. Okay, whether this is at this position or at this position, it doesn't matter. This strip cannot go beyond the region, so it gets shortened or lengthened as you move along x-axis. So always at every instant, the boundaries of this strip is fixed, the lower boundary by y equal to 0 and the upper boundary is always fixed by y equal to 3x actually. So we write it as y is equal to 0 to y is equal to 3x actually here. Okay, then in the complete region, what is the minimum value of x and maximum value of x? The minimum value of x starts here and the maximum it goes up to this point. So the least value of x in the domain is x equal to 0 and the largest value is x is equal to 9 actually here. Okay, so these are the values. So now you got this integral in terms of limits. You know how to integrate. Let's integrate. I is equal to integral x is equal to 0 to x is equal to 9, of course. And if you integrate this, since x is a constant times into 1, so it's like a constant, so constant into y, and y is going from 0 to 3x actually, times dx. So if you substitute this, x is equal to 0 to x is equal to 9, and ultimately if you substitute 3x minus 0 is 3x, so x into 3x dx. So it's like integral x is equal to 0 to x is equal to 9, 3x square dx. So this integration is x cube, that's it. Okay, from 0 to 9. So this is 9 cube actually here. So what is the meaning of 9 cube? 9 cube. So 81 into 9, so 729. That's all. Correct? So 729 is the value of this particular integral in this case. Got it? Did you all understand how we actually write the limits? Of course, I'll also show you with respect to x by x as first integrating variable, but taking y as the first integrating variable and deciding for y. Is this clear? So could you please repeat on how did we decide for y? Yeah, if you move, no, I have just taken y is my choice. Okay, taking y as the first variable of integration is purely my choice. Okay, I'll also show you by taking x as first variable of integration. Okay, is this clear? No, my point is, if you decide that treating y as the first variable of integration, if you wish to take y as the first variable of integration, did you understand how I have written the limits? If that's understandable, it's fine. Okay, because you can choose y or you can choose x, doesn't matter, and we write the limits accordingly. I'll show you when I take x as the first integrating variable how the limits change. I'll show you. But is this clear to all of you? Yeah, Alex. Fine. And this double integrals are very helpful in probability especially. Okay, so normally we have something called joint distribution functions. In such case, we do a lot of double integrations, and all these techniques are very helpful for computer science and this data science student. Okay, y equal to 3x is not clear, sir. Yeah, if you move this strip, the upper bound, see, lower bound is y equal to 0 always. Okay, you take this strip and you move anywhere in this region, always the lower boundary is given by y equal to 0 and the upper boundary is given by this line. Okay, so the equation of that line is y equal to 3x. Okay, Alex. So wherever you move, it's always bounded by this orange curve, which is y equal to 0, and always bounded by this yellow curve, which is y equal to 3x. So 0 to 3x is the change in x at any given location. That's why y limits are going from 0 to 3x. Okay, is this clear? Now, I would have told this answer very easily without even doing this calculation. Okay, as soon as you give me this region and as soon as you give me this integration, I would have straight away told the answer is 729 by just doing one calculation, just one line calculation. Okay, so I'll ask you one thing. So what's the meaning of lower and upper bound? Means this strip cannot go beyond this. Okay, bound is nothing but boundary. Okay, lower bound is nothing but the value of y cannot go beyond 0 because the region ends there. Okay, so that's the boundary up to which the strip can land. Okay, it cannot go beyond that. Similarly, this is the upper. Okay, yeah, I'm getting now. Obviously, I'm responding as well. Fine. So did you get this? Is this clear to all of you? Yeah. So let's see. Now the question is how I can tell in single way. Technical summit. Thank you. So let's see how we can actually calculate this answer as 729 within a single step. Many of you might have seen some interesting stuff. Something like if you have a domain area A, let's say, and maybe this is the origin x, y, origin somewhere here. Have you seen this formula anywhere? If this is the centroid of this region, let's say x bar comma y bar, many of you might have seen x bar is equal to integral over a x dA by integral over a dA, or basically area A directly. Okay, so this integration of derivative is nothing but total area of that domain. So this is integral over a x dA by a area, which is the total area, and y bar is equal to integral over a y dA by integral over a dA, which obviously gives you again integral over a y dA by area. Have you seen these formulas actually anywhere? You might have seen, definitely. 11th class NCERT, centroids. There is something called Pappus theorems. Have you seen them? I mean, this, the least case, are you getting the name at least? Pappus theorems, P-A-P-P-U-S. Some people call it as Pappus theorems also. Cooling, like plus one physics mostly in centroids chapter. You will get centroids and center of gravity is a chapter. So I think you might have seen. Or else, if you haven't seen, then at least in engineering, when many of you have studied engineering mechanics, you might have studied this thing. Correct? So if that's the centroid of that particular area, then ultimately the coordinates of the centroid are calculated by these double integrals. Correct? Have you seen this? To be honest, I don't remember. It's okay, fine. Okay. So in such case, this implies, or else maybe, so this implies if I give you over some area x dA, this value is nothing but the total area A multiplied with x coordinate of that area, correct? Because if you throw this A here, it's like A into x bar is my 11th fully waste. It's okay, don't worry. See, nothing is waste. You always had an experience, either a good or a bad. Okay? And bad experiences will always motivate you to not commit them again and move towards a correct path. Okay, so nothing is like failure or waste. Fine. Most importantly, failures are very important things in life, because once you fail, you'll come to know that there's a path in which you should not go actually. Like it's like, let's say for example, if there's a town which is towards east, but I can keep my full effort walking towards north. Okay, obviously I can never find that town. It's an experience, right? So we can guide the others. Okay, or else in our life, whatever the past experiences we have in the 2-3 years, we use them to progress in a good way in the upcoming 2-3 years. Everything is a nice experience. Fine. It was a horrific experience by 12th and 11th. It's okay, don't worry. So just, it's never late to start learning. Okay, so start from there. So chalo, if this is what you have, and I have asked you the same question here intentionally because I want to show you this logic. So this is purely mathematical way of solving integral x dA. So we have integrated blah 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 and we have got the answer 729. So let's see for this figure. Let's say for example, if I call this point A and if I call this point to be B, for example, if I calculate this integral of area into x dA, it gives me area of that figure into centroid. Okay, so therefore if you calculate this area, so this implies also, note, maybe I'll write as note, integral over the area x dA is equal to A times x bar. You know this. Okay, now what is the region A which is bounded? So area of the triangle OAB, because OAB is the guy which is bounded by these curves. So area of this domain A is area of the triangle OAB. So what is the area of the triangle OAB? Half into base into height. So base kitna, what is the value of base total? Base is 9. And what about height? Can someone tell me if x coordinate is 9, so if point A has the x coordinate 9, then this point lies on y equal to 3x, so y value is 27, of course. Okay, so y is 27, so the height is actually 27. So this is the area of the triangle, and all of us know area of the triangle is 1/3 on this vertical side. So if this total, let's say if the centroid is somewhere here, okay, so this is G, for example, the centroid, common notation, then this has the coordinates of x and y. And what about this length? Actually, it's always measured from the axis, y axis, so x is always measured from the y axis. So this length of the centroid is nothing but, if this is 1/3 of the total base length, this dimension is 2/3 of the base length, correct? So this is 2/3 times of this base length, which is 9. So centroid is at a ordinate of 2/3 9. X coordinate of the centroid is 2/3 2/3 into 9, correct? Can you all agree with this till this point? Yes or no? This is area, and this is the location, x coordinate of the centroid from y axis. Yeah. Okay. No. Yes. Something. Can you get this? This is area, and this is the x coordinate of the centroid, obviously, for that figure. It's a triangle, it's a known geometry, so I'm doing it. Okay. Yeah. So if you simplify this result, sorry, something has happened wrong now. Just a minute. This multiplication, so 2 gets cancelled, and 3 cancels 9 times. So 9 into 9 into 9 is 9 cube. Okay. How did that 27 arrive? Because this length is 9. So if this length is 9, any point on this line has x coordinate 9, correct? So this is the line x equal to 9. So any point on this line is having x coordinate as 9. Okay. So this point A is the common intersection of x equal to 9 and also y equal to 3x. So any point A should satisfy both the equations. So x coordinate should be 9 because this line is x equal to 9. Also, if you put x equal to 9 here, y equal to 27, so that y coordinate at that point is 27. Okay. So if this is 27, 9 comma 27, then ultimately this height is 27. Got it? Yes or no? Please type it in the chat box. Yeah. Just a second. I'll have water again. Yeah. Okay. Did you all get this? This single line answer. Fine. Then let's continue. I'll give you one more question actually. So let's calculate, or not this, maybe this first. Let us calculate this. So can you do this question? Come on, do this. The value of the integral. This is actually one of the test series question. Okay. Any batch for ESC 25 civil engineering starts from this August, sir. August, I think there's an update actually. So just keep following this channel. They keep rolling up. Okay. So every batch launch gets rolled up. Okay. So just keep focus on this channel. Okay. And this is actually a question from our test series. Okay. So we have formed this question. So basically we make test series in such a way that we actually make sure the final questions and these questions have a good replica. Okay. Like, it's not a shortcut. Basically it's like a the common physical understanding of the integrals. That's it. Okay. I'll give you a bunch of integrals and applications of integrals, so where you can calculate. Okay. So this is a test series question, and again basically you might have seen in the maths PYQ book, almost we have solved some 1000 plus PYQs actually, out of which 580 570 plus PYQs are solved by me, and we also have Chetan sir who have solved some other questions as well, and now Punit sir has also come up in the team. So we are setting the test series in such a way, using all our expertise, we make sure the questions which we are writing in the test series and the final questions which come in the GATE examination have a strong replica of each other. Okay. So that's why we make sure this test series are very good. So if you have time and if you are serious about the GATE examination, just give an attempt about in the test series. Okay. So anyway, just to show you some sample questions, I have put it here, because at the same time you also have to understand the level of the test series as well. So chalo, let's solve this question. The value of the integral over a xy square times x minus y dx dy over the area A between y equal to x square, y equal to x, x greater than 0, y greater than 0, means basically in the first quadrant. Okay. So let's see. Solution. I is equal to integral over a xy square times x minus y. So maybe I'm interested to write dy dx, let's say dy dx. If you want, you can write dx dy also, but let's see how we can change the order of integration. Okay, so first let's say with respect to y is what you have. Then what are the curves? As I told you, so plot the curves. Curves are y is equal to x square, then y is equal to x, and x is positive and y is also positive. So area bounded by these curves. Let us plot these curves. So if you plot these curves, actually origin x and y, of course. So y is equal to x square. So in general you have this. I'm plotting only on the top side because I'm not going to the bottom side actually here. Ashwini, hi. Yeah, okay. So see here, this is actually the curve y is equal to x square. Y is equal to x square, or maybe let's plot little steep so that you have some good geometry. What? So this is y is equal to x square. Let's say this is y equal to x square. I'm plotting only in the first quadrant because it's clearly given x is positive and y is positive. Okay, so whatever I do in the first quadrant. Then y is equal to x. So the line y equal to x looks something like this. Maybe this is y is equal to x. Okay, so this is the line y is equal to x actually here. So y is equal to x. So you clearly understand this point of intersection, and after this these two curves diverge and the area in between the curves never is a finite. Okay, it's not bounded, it's infinite beyond this point. Okay, because this line keeps going, this curve also keeps going but with a less slope. So ultimately what happens is like you have the gap between them. Okay, and the area is not convergent. So let's see if this is the area A which is involved. So this is area A which is involved, of course. Okay, then one point of intersection of these two curves is origin, another point of intersection of these two curves, so this is A. So 1 comma 1 is the other point of intersection actually here. Okay, the reason is if you want to solve these two curves, so let's say if you want to solve this, x and x square value is same. Okay, at the same x. So if you write x is equal to x square, because at this point both the curves are intersecting, so this implies x into 1 minus x is equal to 0. So x is equal to 0 comma x is equal to 1. Then if x is equal to 0, y is also 0, and if x is equal to 1, y is also 1. So this is one point of intersection and this is another point of intersection, like you can see origin and 1 comma 1, of course. Okay, then let's see if you want to integrate this. How do you integrate? I is equal to integral f of x comma y, this is xy square times x minus y, or in general I'll just multiply these functions. Okay, so x square y square minus xy cube. So this is the function actually. Then dy, let's choose the first integrating variable to be y, and then the second variable is x. So when the first variable of integrating is y, then ultimately the limits on this inner integral should be y limits, but these y limits should be in functions of x actually. Okay, so let's see, if your first integrating variable is y, then how do you do this question? So let's see, you can actually take a vertical step, because again we are taking a y as the first integrating variable. So you can see if you consider this step here somewhere in between, and if you move this step anywhere in this domain, ultimately always the lower bound is given by the line y equal to x, and the upper bound is given by y equal to x square. Yes or no? 2? Can someone understand? Please type in the chat box. Is this clear? So if this is x is equal to 1, so anywhere you move this step, always the lower bound is given by y equal to x and the upper bound is given by y equal to x square actually. 2? Yes or no? Please type it in the chat box. Okay, can you all get this? You considered a vertical step in the region, and wherever you move this step in this region, always the bottom value is fixed by y equal to x and the top limit is bounded by y equal to x square. Correct? See, when you decide y as the first variable of integration, take a vertical step in the region at any location, and right from this opening to this closing, you move this step anywhere in this domain. Always this step is x square graph is not this. Sorry, y is equal to y square equal to 4ax now. Oh, sorry, yeah, 2. Thank God you have told it well in advance. Good. Yeah. 2. Sorry, there is a different story actually here. So this is y is equal to x, of course. Let's turn this line slightly up like this. Okay, and y is equal to x square. Thanks for telling here. Okay, this is y equal to x square. So y equal to x, yeah, because when x is less than 0 to 1, x is always obviously large. So this is point A. Of course, the solution is 1, 1. So this is the graph, y equal to x square. Yeah, correct. Thank you. Okay, y equal to x square is the graph. Thanks, Shravan. Okay, yeah, y equal to x square is this. Okay, because this graph, what I have done is y square equal to 4x. Okay, and this is x square equal to 4ay, and whatever the value of x, or negative or positive, y is always positive. Okay, so it's a bowl like this. Fine. So let's see. Now, if you decide y as the first variable of integration, you consider a vertical strip at any domain in the region. Okay, so somewhere here maybe. So this is the vertical strip, and now if you move this strip, the lower bound is always given by y equal to x square, and the upper bound is always given by y equal to x actually, correct? So which means you can write the lower bound is always given by y equal to x square, and the upper bound is given by y is equal to x actually. Did you get this or not? So please type it in the chat box. Y equal to x square is the parabola, which is something like this. In fact, y equal to x square is something like this. Okay, this is y square equal to, x square equal to 4ay, and something like this is y square equal to 4ax. Okay, here we have y is equal to x square, so this curve is what it. Okay, for any value of x, either negative or positive, y is always positive. Okay, Alex. Okay, so y is equal to x square, of course. So then once you write this, what are the x limits? X limits are basically something like, so you can see x limits are, so in this region the least point of x is somewhere here, so x is equal to 0. So the topmost point is here, and here the value of x is 1 actually. Okay, so x is equal to 0 to x is equal to 1 actually. Got it? Because x should be constant limits, and x has the least value of 0 towards the left, which is the origin, and the highest value towards 1 at this particular point. Fine. So what happens when you take the reverse, like upper as lower? There comes a minus sign here. Okay, because in single variable calculus I have already told you, if you have integral a to b some function x, this is minus integral b to a f of x dx. So if you take these integrals in opposite sign, there is a minus sign which comes, and it's very clear. Lower value is the lower function which is in contact to this strip. Okay, and upper function is basically the upper curve which is in contact to this strip. Okay, that's all. There's nothing difficult in drawing this limits. Okay, because this function y equal to x square is actually the lower touching curve of that strip actually. Okay, and y equal to x is the upper touching curve, upper touching strip of the curve. Okay, fine. So let's see if you integrate this. Now it's very easy job to integrate. I is equal to integral x equal to 0 to 1, y is equal to x square to y is equal to x. Then you have x square y square x square y square minus xy cube, xy cube dy dx. Okay, so this is actually question from one of our test series, so 2024. X is equal to 0 to x is equal to 1. So if you integrate this with respect to, so first we are integrating with respect to y. So x square into y square integration is y cube by 3 minus x into y power 4 by 4 within the limits the x square to x dx actually here. Okay, so now if you substitute the limits x equal to 0 to x is equal to 1, then if you take the first value, x square by 3 is constant, then in place of y, if you keep the limits, x cube minus x power 6. Okay, because you know when you substitute x here, it's x cube. When you substitute x square here, it's x power 6. So x cube minus x power 6 minus x by 4 times of, when you put y here, it's like x power 4 minus x power 8, of course. Okay, so this function dx. So it got converted to a single variable integration. You can perform the integration very calmly now. So this is dx obviously. So I is equal to integral x is equal to 0 to x is equal to 1. So let's see, x square x cube, x power 5 by 3 minus x power 5 by 4. So x power 5 by 12 total. I am just simplifying the function, that's it. Minus x power 8 by 3 plus x power 8 by, no, x power 9. Okay. So here you have x power 8 of course into x by 4. So let's do this, x power 8 by 3 plus x power 9 by 4 dx. So upon integration, this guy gives you x power 6 by 72 minus x power 9 by 27 plus x power 10 by 40. So within the limits 0 to 1. So if you substitute 1 by 72 minus 1 by 27 plus 1 by 40 of course. Okay, so this is the value. You can do this. So please slow it down while substitution. I couldn't follow. Slow it down while substitution. Yeah, okay. So it's like treating x and this numbers as constants, and wherever there is y, you are substituting the limits. That's all. Okay. So now if you simplify, what is the LCM of these guys? 72, 27 and 40 maybe, or else let's write the simplification directly. So we have, or else let's do one thing, 1 by 72, let's take a calculator and use this. So 1 by 72 minus 1 by 27 plus 1 by 40. Okay. So if you do this calculation, 0.00185 is the value of the integration. Okay. So this is the integral. So let's see how we can solve this question. We have options 1 by 45, 1 by 450, 1 by 15, 1 by 540 actually. Okay. And this value is less than 0.01. So which means the denominator is more than 100 definitely. So these two options are wrong. So 1 by 450 and 1 by 540. Let's calculate 1 by 540 first of all. So 1 by 540. So 0.00185. So 0.00185 is basically for 1 by 540. 540 is the LCM value of this all numbers actually. So 1 by 540 is the correct answer. Option D is the correct answer in this. Okay. So did you get this? How to calculate the integral? Yes or no? This is one of the questions in our test series, and we make sure it matches with the gate level, and also few questions that are slightly above gate level so that you can solve the gate questions very easily obviously at the end. Okay. Fine. Okay. So let's see one more question actually, or let us try to solve maybe this question using the change of variable of integration. Okay, which we will see now. So change of variable of integration. Let's see the concept. Change of order of integration. Sorry, not variable, order of integration. Maybe I'll teach the volume integrals tomorrow, but let's see. Okay, so change of order of integration. Please give some work at last. Yeah, I'll give definitely. There are questions to do. Okay. So let's see change of order of integration. So when you have this domain, okay, so the integral I is equal to integral f of x comma y dy dx, where y is changing from phi of x to let's say psi of x, and x is changing from a to b, can also be written as can also be written as I is equal to integral x is equal to some function, say h of y, comma x is equal to say some other function alpha of y, y is equal to c to y is equal to d, the same function f of x comma y dx dy actually here. Okay, so here you can understand in this case we maintained y as the first variable of integration. So the limits on the inner function are y limits, but these are functions of x, okay? And ultimately the outer integral has x limits, and these are constants. That can also be written as the first variable of integration being x, and since this is the first variable of integration, which is x actually here, so these are x limits and they are in functions of y actually, and the outer integral is y limits having constant limits, of course, okay? So which tells you in general, so let's say this is x and this is y. So let's say there are 4 curves which are bounded something like this, okay? So there is a region which is bounded. Then in that case, so let's say this is y is equal to phi of x and y is equal to psi of x, okay? And this point is, let's say, or else let's try to do something here, because I have drawn 2 horizontal curves so nicely. So let's see. Something like this, okay? So let's see, this is the curve y is equal to phi of x, and this is the curve y is equal to psi of x, okay? And let's say this is x is equal to h of y and x is equal to alpha of y actually here, okay? And let's say this point here is a comma b, and this point is, sorry, a comma c actually here, a comma e. Let's and this is b comma d. So let's say you have these curves, okay? So that the least value of x is given by like list, okay? So better, then this is x is the least value here, and y is the least value here, and y is the largest here. X is also, again this curve also will modify slightly, something like this, okay? So x is equal to alpha of y. So when you have this, then in such case, however, we always consider the curves on the positive side of x-axis and y-axis. Need not be, okay? Since I'm just drawing the curves, I'm just giving you the functions in such way you are plotting on the first quadrant, okay? There are a few curves which you can plot on second quadrant and take the tips, of course, okay? Maybe I'll give one example tomorrow, so that where you see basically the curve actually lies in the second quadrant or in the third quadrant when you take y, okay? So how did you name ACBD, sir? I'll show you just a minute. So this integral can also be modified in this integral like this, okay? I'll just work an example. You can see, first of all, here the variable of integration is y, so ultimately you have written y limits in terms of x. Similarly, here the integrating variable is x, so you have written. Now when you write this y limits as functions of x, ultimately this x limit should be constant, okay? And x should go from a minimum of a to a maximum of b. So in this complete region, x should go from a minimum of x is equal to a to a maximum of x is equal to d actually here, okay? And the maximum of x is equal to b is somewhere here. So that's why I have taken care that this point is the max, since I have named it as b comma d, x coordinate is b, so this point should be the maximum x coordinate point in the complete region, so x equal to b here. Similarly, when you plot this second integral, y equal to c to d, so y equal to c is the least value of y in this complete domain, and you take any other point, it's above definitely, okay? And this is the maximum limit, y is equal to d. So that's why I have named the points as AC and BD, of course, okay? So let's work out one question. I've given you one question, right? So this question I have just given you as integral of a x dA, and I have treated y as the first integrating variable, and I have solved this question. Now let's solve the same question using treating x as the first variable of integration, okay? So let's see. Make sure when you change the variable of integration, these 4 limits which are on the top of integrals gets changed, okay? So this integrals also change. So many times what people do is they just swap these two and integrate directly, which is a wrong answer, of course, okay? So you should, when you change the order of integration, these 4 limits will also change, okay? So that's what I have represented here. Then let's see example. Let's consider the same example. I is equal to integral over a x dA where A is bounded by, I'm directly writing the curves, x-axis, y-axis, y equal to 3x, and x is equal to 9 actually. Okay, so let's say this is the curve, and obviously if you plot these curves, the same story like previous, we get a triangle origin x, y of course, and so y equal to 3x is the line which is something like this, y equal to 3x, and x is equal to 9, let's say. So x is equal to 9 is something like this. Okay, then so origin of course this point is A, which is as usual 9 comma 27, and this is origin. So ultimately this is x is y is equal to 0, and this is x is equal to 0 actually. So we have solved this question by taking y as the first variable of integration, and we got the answer to be something like 729, right? Yeah, let's see, 9 cubes, yeah, 729. Okay, so let's see. Now we solve the same question by taking x as the variable of integration, first variable of integration. So let I is equal to integral over a x into dx dy. So you have chosen the x as the first variable of integration, so this implies I is equal to integral x times dx dy. Now when you take x as the first variable of integration, see, you remember when we have taken y as the first variable of integration, we have taken vertical strip. Okay, so when you take x as the variable of integration, take horizontal strip in this region. So you take the horizontal strip in this region, of course. So if you take this horizontal strip actually here, okay, and that's point A, of course. Now ultimately these limits should be x limits, and they should be in functions of y, as you know. Okay, now when you move this strip anywhere in this region, always the least value of x is bounded by this line, correct? And what is that line? Y equal to 3x implies x is equal to y by 3, of course. So x equal to y by 3, and here it is x equal to 9. So when you move this strip anywhere, the lowest value of x is always bounded by this line, and the highest value of x is always bounded by this line, x equal to 9. Means the curve which touches where the value of x is less or the least is this curve, and the value where x is largest is this curve. Okay, so it goes from x is equal to y by 3 because that's the least value of x in this region at any point on this strip, and x equal to 9 because that's the largest value, which is a constant in this case. Okay, so x is equal to y by 3 to x equal to 9, it is changing. Now what about y? Y is generally the constant values because it's the outermost integral. So what are the least and highest values of y? So this guy is y is equal to 0, and the top value is y equal to 27. So y equal to 0 to y equal to 27 actually here. Is this writing limits clear to all of you? If writing limits is clear, then integration is a bit of fun stuff that everyone can do. Okay, so writing the integrals is the main crux in this solving multiple integrals. Okay, yes, each and everyone please confirm, is the writing of integrals clear to all of you? Writing the limits, sorry. Yes or no? Okay, so I hope it's clear to all of you. Then let's see. So let's integrate this. I is equal to integral y equal to 0 to y is equal to 27. Then first integral, so integration of x dx, there is no involvement of y anyhow, so direct integration gives you x square by 2 within the limits 0 to y by 3 to 9 dy. So if you integrate this, x is equal to 0, y is equal to 0 to y is equal to 27. Let us substitute these limits. So if you put 9 here, upper limit 9 square by 2, so 81 by 2, minus when you put y by 3 here, y square by 9 by 2, so y square by 18. That's what you have here. So dy actually. So this is what you got. So how y by 3 lower limit? See, I'm telling you, if you move this strip anywhere in this region, always the left limit of this strip is given by this line, Yes or no? See, I'm moving this strip anywhere in this region. The left limit of that strip is always given by this left region. Correct? Got it? Means on this strip anyway, the least value of x is always given by this curve, and the highest value of x is always given by this curve. Like how in case of vertical strip, least value is given by y equal to 0 and highest value is given by y equal to 3x. Similarly, in this case, x least value is given by y by 3 and y least x highest value is given by x equal to 9. So that's why x equal to y by 3 to 9. Okay. Is the x limits clear? Then y limits. So ultimately y limits has to be constant. So in this complete region, the point where y is minimum is any of this point on x-axis. So on all these points y equal to 0. So you can take y equal to 0. And the highest point in this region has y equal to 27. Okay. So we had this. So how did you get 0 and 27 for y? Like this, no? So as I'm telling you, the least value of y in this complete region is 0 on this line, at any point on this line. Okay. And the highest value of y is at this point, this region. Fine. Yes. Is this clear to all of you? Did you all understand why the lower limit of y is 0 and the upper limit is 27? Because the complete region is distributed with the least value of y to be 0 and the highest value of y to be 27 actually. Okay. Yes or no? Something? Fine. So let's integrate this. So if you integrate with respect to x, then integration of x is x square by 2 within the limits 9 to y by 3 to 9. So if you substitute 9 square, 81 by 2 minus, when you put y by 3 here, so y by 3 whole square, which is y square by 9 by 2, so y square by 18. So if you integrate this, we have 81 by 2 times y minus y cube by 18 into 3, which is 54. So the limits is within the limit 0 to 27 actually here. Okay, so this is 27. So let's compute the values. 81 by 2 into 27 minus, what about this guy? Y cube by 54. So 27 cube by 54 actually. So let's perform this calculation and let's check how the value. 81 into 27 by 2, 1093.5 minus 27 cube by 54. Okay, so 27 cube by 54. So if you simplify, 729 is the actual answer. Of course, it should be 729 because whatever the way you calculate it, the answer should not change, the integral should not change. Okay. Obviously, that's what I'm telling now. When you're writing the constant limits on the outermost integral, the lowest value is the lower limit and the highest value is the upper limit. Right? In that region, in that domain up. Okay, so for this triangle, the least value of y is given at by any point on this line. So y equal to 0 is the lowest value and y equal to 27 is the topmost. So that's the higher limit, upper limit. Okay, so this answer is 729, of course. So why we are interested in choosing this change of order of integration? Sometimes in the direct way, the integration of the integrand becomes slightly difficult. So in such case, by changing order of integrations, the integral becomes solving the integration becomes slightly easy actually for you. Okay, so that's the reason. So anyway, I'll give you one homework question because I think it's okay. We'll take one more lecture for multivariable calculus and we will figure out the things, but it's okay. So we'll solve this question. It's a homework question. Homework. Okay, so that's actually a homework question. And yeah, okay, fine. That's only one question which I want to give as homework for today. So integral 0 to pi, integral y to pi sin x by x dx dy is what you have. Okay, so solve this question in integral in homework. So in tomorrow's class, basically we'll see applications of multiple integrals. There are some nice applications where you calculate things like moment of inertia, centroids. Okay, lot more of course. Okay, then we also come across coordinate transformations. Okay, changing an integral from one system to another system, how we change that. So these things we're going to do, like from Cartesian to polar coordinates or polar to Cartesian or Cartesian to some other coordinates if you need. Okay, so we'll see what's the common technique in converting the integrals from one variable to another, one system to another system, and also we'll look at volume integrals. Okay, fine. So this is the homework question then today. So basically in today's class we have seen some small techniques on multiple integrals. Multiple integrals, we have seen how to calculate them, and also change of order of integration. Change of order of integration. Okay, so these are the two things which we have seen basically in today's lecture, and we have solved some questions. Okay, so again we'll meet tomorrow at 7 p.m. of course, and tomorrow's class is like very interesting. You'll see a lot of fun things, like how you have seen applications of single variable integration, some nice curves like finding length, all these things. So we'll again see certain nice things, calculating moment of inertia, all these things tomorrow's class. And so that's all. Okay, and also we are putting some questions in the test series so that you'll get an idea. So plan to write a full test series. Okay, it will be very helpful to you. Fine. So any quick questions if you have, it's fine, or else it's okay. Just type it in the chat box. Have any quick questions? Did all of you understand the way to calculate multiple integrals today? So I have sent you a question on Telegram. Could you please have a look at it? Just a second. Phone. Yeah, my phone is 7 stars. Has sent us a question. Let's see. Phone has some running at Telegram. Then you have sent me maybe. Let's check it up. This is a general question. I'll answer it. Okay. I thought some technical question. Okay, it's a general doubt. I'll reply it. Fine. So thank you all. We'll meet then the PYQ. That PYQ we have solved now already. AX minus lambda x in matrices. In the last lecture we have solved it, right? You remember? Not in the last to last lecture we have solved it. A minus lambda I operating on x is equal to 0. That's not. That's the question, right? What you have sent me. Not that question. In the group you have sent. Let's have a look at it. The group. Okay. Group, where is it? Here it is. Where is the question? In the complex numbers one. Is that you're talking about complex numbers? Yeah, that I'll solve when I start complex numbers. Okay, because again, some people have another problem of order 2n. Where it is? Could you just quickly tag that? Okay, so that I can solve. Maybe. Because next question. Another problem on the order 2n. Okay, I'm not finding it. Could you quickly tag that question so that I can answer quickly a bit. I'm seeing only one question here. Order of n square. Yeah, this is the question we have solved right in the last class. Yeah, this is the question obviously which we solved in the last lecture. My Telegram, only one question is coming up. Like this question what I have solved in the last lecture. Ax is equal to lambda x. That question. So I don't know how to approach. What is the difference between? Okay, there is one more question. I'm finding only one question here. It's okay. Yeah, you just sent me again because you can see there's only one question here. I cannot show you, but there's only one question which is on matrices. Cannot see. You can see only one question is there. It's okay. You send it again. Maybe I'll answer it to you. Okay. So thank you all. We'll meet tomorrow at 7 p.m. and we'll discuss the things once. Okay. In the multiple integrals. Thank you.